In this video, we'll learn how to determine the required sample size for estimating a population proportion. When we're trying to determine the sample size, there are two possible formulas. The one we use depends on whether a previous estimate of the population proportion is available. If the previous study or survey gives us an estimate of the population proportion, then we use this formula. N equals P hat times Q hat times Z sub alpha over 2 over E squared. Notice that these two formulas are the same. Some textbooks use P prime and Q prime instead of P hat and Q hat. They represent the same quantities, so don't let the notation confuse you. P hat is the previous estimate of the population proportion. Q hat equals 1 minus P hat. E is the margin of error. And Z sub alpha over 2 is the critical value determined by the confidence level. If no previous estimate is available, we use this formula. N equals 0.25 times Z sub alpha over 2 over E squared. Notice that this formula is a little simpler because the value 0.25 replaces P hat times Q hat. In the next video, we'll talk more about why we use this formula and when it's appropriate. For this video, our example gives us the previous estimate, so we use the first formula. And remember, always round the required sample size up to the next whole number. Let's look at example 4. A previous survey estimated that 82.4% of adults own a smartphone. What sample size is needed to estimate the population proportion within 3 percentage points at a 99% confidence level? Let's identify the information given. The previous estimate is 82.4%. That is our P hat. So P hat equals 0.824. Q hat is 1 minus P hat. So Q hat is 1 minus 0.824, which equals 0.176. The margin of error is 3 percentage points, so E equals 0.03. Now we need the critical value Z sub alpha over 2, and we use the 99% confidence level to find Z sub alpha over 2. So first, let's sketch the standard normal curve. The center is 0, and 99% is the middle area. So this middle area is 99% or 0.99. Alpha is 1 minus confidence level, which is 1 minus 0.99, which is 0.01. Alpha is the remaining area, which is these two tails. We split that equally between the two tails. So alpha over 2 is 0.01 over 2, which is 0.005. So this area is 0.005, and this area is 0.005. The two boundaries are negative Z sub alpha over 2 and positive Z sub alpha over 2. The one on the left is the negative one. and the one on the right is the positive one. And for this formula, we need the one on the right, z sub alpha over 2. We are going to use the inverse norm function on the TI-84 calculator. We need the left area, mean, and standard deviation. This is the value z sub alpha over 2. We want the area to the left of this value, including 0.99 and 0.005. So everything to the left of z sub alpha over 2 is 0.995. Mean is 0 and standard deviation is 1. Now, we use the TI-84 calculator to find this value.
To open the distribution menu, press second vars, choose inverse norm, and press enter. For the area, we'll enter the left area, 0.995. Mean is 0. Standard deviation is 1. Choose the left option because we used the left area. Highlight paste and press enter. Press enter again. This is our answer.
And we get 2.5758-29303. And we normally round the cuticle value to 2 decimal places. So we get 2.58. Now we're ready to substitute everything into the formula. This is the formula that we're using. We'll replace p hat with 0.824, replace q hat with 0.176, replace z sub alpha over 2 with 2.58, and replace e with 0.03. And we put everything in the calculator.
So we take 0.824 times 0.176 times, open parentheses, 2.58 divide 0.03, close parentheses, squared, and press enter. This is our answer.
And we get 1072.597504. Since the sample size must be a whole number, we always round up to the next whole number. So we get n equals 1073. This means the company should survey at least 1,073 adults.